In this video, I am going to explain very important points about the SN1, SN2 mechanism, and it is explained by optical activity. So, optical activity is basically a tool to provide the stereochemical evidences of SN2 and SN1 reaction. Stereochemical means, first stereo. Stereo refers to 3 dimension or a space, and chemical, there is some chemical change. So it refers to the 3-dimensional chemical relations. So before first see optical activity, so it is defined as the rotation of axis of plane polarized light when passed through optically active. We will say optically active, meaning optically active enantiomer. Enantiomer means optical isomer. When passed through optically active enantiomer, optical isomer is called as optical activity. It is called optical activity, or simply it is called as optical rotation. So, optical activity means activity towards the light, activity towards the optics. So, first we will see the plane polarized light. Ordinary light, the quantas or the photons, this is ordinary light. The photons or the quantas, they vibrate in all the axes, and this is having the rotation, the vibration of the photons in all the directions. When it is passed through a special type of prism, it is, you almost knowing from physics, Nicol prism. Nicol prism is a pair of prism of a special type of glass having such tendency to produce only the monochromatic light. Monochromatic means the light radiations having only one frequency, only one wavelength. So after that we have the photons or the quantas having this type of vibration. This is monochromatic light or monochromatic rays. When these monochromatic rays, they are passed through, here in the vessel we have the enantiomer. We have enantiomer or optical isomer. So here there can be two conditions. If it is enantiomer 1, if it is enantiomer 2. So here, if in 1, if it rotates towards this side, this is right side rotation. Right side rotation. In other, when it pass, if it is left side rotation, it is left side rotation. Right side rotation and left side rotation. Right side rotation and left side rotation. So see, when we pass this monochromatic light through enantiomer or optical isomer, then there are two types of enantiomers. if one enantiomer rotates toward the right hand side, then it is this enantiomer one, it is called as dextro. It is called as dextro-rotatory. Dextro-rotatory, and it is called as other one levo-rotatory. So dextro-rotatory towards the right side. Dextro-rotatory enantiomer rotates toward the right side, and this enantiomer, it is written as D or it is written as plus. Before name the prefix D for dextro or plus. Similarly here for this we write small l or minus as the prefix. So this is about the optical activity, and it is very important tool to understand the stereochemical aspect of the SN1 SN2 reactions. Now you must be wondering why optical activity is exhibited. So actually optical activity is exhibited by some special type of molecules, and such molecules are having the chiral carbon. Chiral carbon, some persons may say chiral carbon, so it is up to you, but it is chiral carbon, and it is also called as asymmetric carbon. So it is related to the property, and the property or the nature of the carbon is called as chirality. So what is the meaning of chiral carbon or asymmetric carbon? When all the groups or atoms attached to the carbon are different, then it is said to be chiral carbon or asymmetric carbon. When all the groups are different, it is said to be asymmetric carbon, and so this is the only and one prime condition for optical activity. So this is important to note that the substances having chiral carbon shows optical activity. If the substance is optically active, it means it has chiral carbon. And if substance having no chiral carbon, no optical activity will be exhibited. No optical activity will be exhibited. Now some important points how to identify the chiral carbon. Actually here I am drawing this letter A. Here the object, here there is a mirror, and here there is the image. Now if we take the image and put over this, it means the image and object are superimposed or they are superimposable. Then this decides an object or the enantiomer will be a Kiran. It will be a Kiran. So the object and the image, when they are superimposed or superimposable on each other, then this is said to be a Kiran. Now coming to other point, here same mirror. Here I am putting here object A. Now here we have the image. Now here object and image, they cannot be superimposed. So here the image and object cannot be superimposed. So thus object or enantiomer will be Kiran. Kiran means it will exhibit optical activity. Optical activity will be exhibited. So this is the second condition. Now see some such molecules which are not here. So this is propane 2O. So this is the Kiran molecule. Here this is the object, here the image, and so they cannot be superimposed on each other. So here it will be Kiran. It is Kiran molecule. Now next is racemic modification or racemic mixture. Racemic mixture or racemic modification. So very simple. When the two enantiomers, that is D and L form, are in equal quantity. So when the dextro and levo rotatory enantiomers are present as a mixture in equal amount. It is present in equal amount. So no optical, what will happen? No optical activity. No optical activity is exhibited. So this mixture will not be having any optical activity, and such mixture is called a racemic modification or racemic mixture. Why? Because if D form or dextro rotate toward the right side, so levo will rotate toward the left side. So what will happen? They will cancel the rotation or degree of rotation. So the light will be passed as monochromatic light. So this is racemic modification or racemic mix. Now opposite is racemization. Racemization, it is separation. It is separation of D and L isomers. D and L isomers from racemic mixture. It is racemization. So racemization is a process. It is a process. It can be physical, it can be chemical depending on the nature. So this is racemization, the separation of racemic mixture or racemic modification. Now next is retention of configuration or retention. So as name indicates, it is English word. It means to keep some title or property or anything special point with same, like any team wins a race, wins a match, we have any world record. So what we say that the team was able to retain the title. Similarly, so it is the ability due to which the groups present in a chiral carbon are able to maintain their relative positions after reaction. So the position, it is maintained to be same. See here again coming, if it is CS3, here it is C2S5, and here H, and here it is OH. So if there is, this is the reactant, and if it is kept as it is, see there, if there is any attack of nucleophile or anything, and so if the groups, they are again to be same at the same position, this is, so any the product, any compound, so here this is the product, and so this is said to be the retention. Now opposite to that is inversion. See how? Now inversion is basically inward, just in different directions. So it is the ability of a molecule, and which type of molecules? Skilled molecules, due to which the relative positions of different groups, are reversed or are inverted after reaction. Just opposite, like in case of inverter, when main supply is on, power is on, what happens? Inverter is silent, no work is except charging the battery. When main supply goes off or fuse is blown off, what happens? Inverter starts working. How? The current stored in battery, it is able to convert DC into AC, so it is there. Again, when main supply is restored, what happens? Inverter stops working and it starts charging, so it is inverter. So same is the case here. Like say, see here, watch. You can take any example. So this is the reactants, and see here, if the conditions are just opposite, this is the product. So this is said to be the inversion of configuration. And next point is mutarotation. So mutarotation is the angle of rotation. Angle of rotation by chiral objects for the monochromatic light. Monochromatic light is called mutarotation. It means, their angle can be different. If it is rotating to 20 degree, if it is rotating to 30 degree or 45 or 180. So this is the mutarotation. So mutarotation simply means the angle to which the axis is rotated. And so these tools are very much important to study the confirmation about the SN1, SN2 reactions.